You've seen the video on the lab notebook and how to set up the lab notebook. Now this explains the requirements that go in a formal or written lab report. Your lab report is divided up into sections. Each section has a header. For example, one section is introduction. Okay, then sometimes this is also known as objective, the objective of the lab. Then you have a section called materials. A section on procedure. Data. Analysis, and then finally the conclusion. Those are the things you need. Now we're going to look at what goes into each individual section. The introduction or the The introduction or objectives is a beginning of what you're looking at. It is basically a statement that summarizes what you're looking at, so what are you examining, what you think, is the cause, and why you believe that. You will be doing many things. For example, in one of the labs we did, you had to determine the strength of the bridge. So you look at, in a bridge, the strength I feel is dependent upon the distance between piers. Therefore, I am going to test my bridge's strength by changing the separation distance. Okay, so notice what we've done. We've stated what we think the bridge is affected by, and we stated how are we going to test it. So we have our test criteria, and we have what we think. Okay, this is kind of like our hypothesis. If I change my separation distance, something's going to happen. Is the bridge going to break? Is it going to get stronger the closer they are? Is it going to be weaker the further apart they are? This is what we're testing. The next section is our materials. Your materials should have a list of items used and a sketch of your setup. After your materials is procedure. Your procedure should have safety concern, that way safety is always on your mind because we want to be safe in doing these labs. It can be a step-by-step guide, or you can do it in paragraph form. Your choice. I personally have no preference on if you do it as a paragraph or if you do it as a step-by-step guide. However, the thing is, it has to be done so somebody can read what you did and understand what you did enough to repeat the lab and get similar results. So this information must allow someone to repeat it. So it has to be repeatable. After your procedure is your data. And this is data tables. Okay? It can be set up like this, whereas you have a trial. And let's say for our spaghetti or our bridge, distance separating, and the number of pennies. And you can do 1, 2, 3, 4, your choice. Or you can even leave the word trial off and just do distance and pennies. However, you have to have a data table. And one important factor is we're using a distance. What distance? So you need to have centimeters somewhere. So it would be like distance in centimeters, and then the number of pennies. Your data tables are going to change all the time based on the labs you're doing. So you have to think what you're measuring, what you're needing to know. Are you going to have another column for an average if you're taking multiple labs and multiple trials to get an average to get one number to plot? After you get your data, then you graph your data. And a graph has to have very specific things. A title has to have axis labeled. A best fit line. And slope. Well, what if our line is not linear? If your line is not linear, you have to linearize it. and then repeat the process. But all graphs have to have a title, our labels, best fit line, and slope. After the graph, which is part of the analysis, you could have questions. It varies by lab. Some labs I give you will be a CAN lab, and you have to answer specific questions. This is where it goes after your analysis or after your graph. The labs that we have been doing lately are not canned labs, or where I hand you a piece of paper with all the information on it and you fill in the blanks and write it up. It's where you have to think about things. There is no question segment on those type labs because it's how you produce your answer. The final thing in all labs is your conclusion. Your conclusion is the summing up of what you found. Okay? A conclusion has to have a statement on what you looked at, what you found. Okay? So looked at, found, out about. This uses data. And that data is your slope. And then you put in errors. If there was any errors, why you think those errors could occur. How bad of an error. On some labs you will be doing an error analysis. This is where that information goes. I hope this short video helps in the explaining of my expectations on what is written in a lab report.